This video is aimed at Schemp Hirth, VTC standard Cirrus, Glasflugel, and the Slingsby Kestrel sailplane gliders. Over the years, we have found that people can occasionally miss when the gliders have been broken. And what we intend to show you here is ways of finding out whether your gliders are broken or not. Not the only ways. This is just one version of looking at how things work. So typical T-tail, you have a lot of leverage at the top of the tail, and if you put any side load through the tail wheel area, um, and the what you find is the fin flexes, and you get a lot of whiplash left and right, backwards, forwards, huge amount of stress on the base of the fin, and the whiplash at the top of the tail can often bend or twist the metal U bucket at the top of the fin. And what does this U bucket look like? Here we have a picture of one. So you have the two elevators left and right, all bolted together, three bolts either side, with a bit of metal in between. And in this case, as you can see, the metal is completely severed. It's broken. What caused this? Almost certainly a ground loop or something along those lines. And you can see it's all covered in grease. Part of the annual inspection, it really should be taken to bits every year and fully inspected, because you can get twists, not just in this area, in other areas as well. And not all of it is easy to see if it's the other side of the on top surface, the fairing and so on. So when you take these to bits, be very, very careful to make note of exactly how many washers and spacers go in various different places. Because if you USB assemble it incorrectly, you'll find you get stiff points. You can start pulling nuts out of elevators. You can damage the bearings by tightening them sideways. So make sure you take careful note of how it's built in the first place. If you lose that information, you can spend hours trying to sort it all out to get it so it's friction free without binding on anything or causing any excess stress in any other areas. But that's life. The elevators, as part of a daily inspection, should be checked to see whether the glider actually has a twisted elevator. If it does, it usually means the metalwork is twisted. And that's a fairly obvious trick you can do during normal pre-flight inspections. And here we have a picture of an elevator of a glider which actually has had a proper ground loop. And as you can see, the elevators are quite twisted. So that tells us the metalwork is twisted. And if it's twisted, there's a good chance it's broken. And here we can have a more insidious crack, not like the one you saw earlier, where it's only cracked through a small proportion of the radius, actually, of the tube. And the cracks often appear, not always though, from the pins themselves, where you insert this onto the fin of the glider through a tailplane pin, and the crack starts from there. And here we can see a slightly bigger crack that, when they went a bit further, got a bit worse. And as you can see, the cracks can vary in size and intensity and direction, but whenever it's overstressed, it can happen. It's a fact. And these are very common. You don't need an airworthiness directive to tell you there's a problem. You can see it. It's part of annual inspection. You shouldn't be missing this. Apart from routine stuff. The bearing at the elevator root end, it's quite easy to damage this by getting the spacing wrong. It can't, although it can take great vertical loads, it can't take very high sideways loads. The other aspect of life here is it's worth, when you're taking the elevators off, checking the bearing is smooth, because in real life it might often do 3 or 4, 5,000, 6,000 hours without ever being changed. But if it's only ever moved through like a 20-degree plane of rotation, then you'll have lots of wear and tear through that 20-degree rotation and not in the rest of it. And when you put your fingers around it and twist it, it'd be like a rigid, really knobbly 50 piece type thing to actually move. So do check the bearings when you're doing these as well, and obviously change the bearings if required. And here we have a elevator hinge that's breaking. It's been broken for years, and you can see all grease in it. The reason these often get missed is mylar is covering the hinges. You can't see it easily. So always try and inspect these from the inside, which means again having to keep them clean and to take the U bracket off if required. Because taking the U bracket off doesn't usually involve taking the mylar off. And here you can see a crack that's fairly obvious. And it can be pushed off as well by just in a trailer. If you just move the elevators downwards with some force, the metalwork can push the top skin off the hinge and break the hinge that way as well. So it's not just flight loads that can break these hinges. Here we have a very short video. Ground nukes, and you can see the damage to the obvious. And I hope that helps. Works with the British Gliding Association. And if you ever find any damage or problems like this, please feel free to email it to us, the British Gliding Association, so we can add it to our list of images. We can help share and make everyone more aware of how to find problems with gliders. And goodbye. Thank you for listening.